Assalamualaikum and hi everyone. This is 7.1 part 3. So here are the learning outcomes. At the end of this lesson, students should be able to relate pH and pOH to the ionic product of water Kw at 25 degrees Celsius. And then we are going to define pH, pOH and pKw. Next, last one, we are going to do calculation on the pH values of a strong acid and base. Are you ready, guys? Let's go. Right, pH and pOH. Have you ever heard of the word pH before? I guess yes. How about pOH? No, not yet. But don't worry, we are going to learn about pOH in this lecture. Concentration of H2O plus ion in a solution is measured by using the pH scale method ranging from 0 to 14. pH. What is pH? pH is defined as the negative log of the concentration of the hydronium ion concentration. Therefore, when written as a formula, pH equal to negative log concentration H plus or H2O plus. Therefore, if we do the calculation, if concentration of H plus ion increases, the pH value decreases, or vice versa. How about pOH? pOH is defined as the negative log of hydroxide ion concentration. Therefore, when written, pOH equal to negative log concentration OH minus. So how does the concentration of hydroxide ion give effect to the pH value? So if the concentration of hydroxide ion increases, pOH value decreases, pH value will increase. But how does this happen? So we are going to look through the relationship between pH and pOH later in the video. So here is an example of a pH scale ranging from 0 to 14 of our everyday life basis. Okay? So the lower the pH value, the stronger the acid is. Meanwhile, the higher the pH value, the stronger the base is. Auto-ionization of water. Auto means automatic. So water is actually a unique compound. It do undergo self-ionization. Okay, even though it does not react with anything, it do ionize. Okay, so but water dissociate into ions very slightly. For example, written the when you see the word slightly, that means how are we going to write down the dissociation equation? It must be represented by using the double-headed arrow here. So H2O, okay, dissociate forming its ion, H2O plus and also OH minus ions. So this brings to the expression of Kw. What's meant by Kw? Kw is ionic product of water. So we can see here from the dissociation equation, water produce ions. What are those ions? Those ions are H2O plus and also OH minus ions, right? So we can see here when it says ionic product, that means we have to times the concentration of those ions present, which is the H2O plus and also OH minus. Easy, right? Therefore, Kw can be expressed as concentration of hydronium ions times concentration of OH minus ions, because it said ionic product. Product means time. In pure water at 25 degrees Celsius, concentration of hydronium ion and hydroxide ion is equal to each other. So it brings the value is 1.0 times 10 to the power of negative 7 molar. Therefore, substitute the value into this equation. Kw is equal to 1.0 times 10 to the power of negative 14. This is a constant value. We say ionic product of water in pure water at 25 degrees Celsius. So this is a constant. And it, as you can see, it is dimensionless. Dimensionless means it got no unit. So, relationship between Kw, pH and pOH at 25 degrees Celsius. As we know, H plus and OH minus ion are correlated to each other by using the Kw expression. So taking negative log both sides, we're going to do some math here, bringing up to this equation. pH plus POH equal to pKw. So now we already have the value of Kw. Okay, at 25 degree, the value of Kw is 1 times 10 to the power of negative 14. Therefore, substitute the value. We're going to get this equation. It's a very important equation in this topic. So pH plus POH equal to 14. You have to remember this. Okay, this is the relationship between pH and POH. Next, relationship between H2O plus and OH minus. Both ions are present in all ecosystems. Remember, by using the Kw expression. Therefore, a change in concentration of hydronium ion causes an inverse change in the concentration of hydroxide ions. The higher the concentration of hydronium ion, the lower the concentration of OH minus ion, and vice versa. Therefore, when in a solution, whenever the concentration of hydronium ion exceeds the concentration of hydroxide ion, it's going to be acidic solution. But when the concentrations of both ions are equal to each other, it's going to form the neutral solution. And when the concentration of OH minus ion or hydroxide ion exceeds the concentration of hydronium ion, it's going to form the basic solution. Okay. Next, we can calculate the concentration of H2O plus ion and OH minus ion in aqueous solution by using the Kw expression. By now, I think you can memorize already the Kw equation, okay, because we are going to use it a lot in this chapter or in this subtopic. So, by using this equation, if we want to calculate the concentration of H2O plus ion, that's mean Kw over concentration of OH minus ion. When we want to calculate the concentration of OH minus ions, that's mean Kw over concentration of H2O plus ion. Simple math, right? Okay, so we move on to the next slide. So, strong acids and bases are considered to be 100% dissociated in an aqueous solution. Remember that, right? For example, we have here strong acid, HCl. So when dissociated in water, okay, it is going to be dissociated completely. So initially we have 0.02 molar HCl. So from this dissociation equation, we can see that 1 mole of HCl produces 1 mole of H3O plus ions. So in order to calculate the pH, we must focus on the hydroxide ion. We must focus on the hydronium ion. So now 1 mole of HCl produces 1 mole of hydronium ion. Okay, therefore, initially we have 0.02 molar of HCl acid. It's going to produce 0.02 molar of hydronium ion. So just substitute the value of the concentration into this equation. Okay, so we are going to get a value of 1.70. So please write down or please calculate the pH value up to 2 decimal places. Okay, so now we are going to calculate the pH of a strong base. Let's say we have calcium hydroxide here. So first, please write down the correct dissociation equation. Calcium hydroxide dissociates into its ion, which is calcium 2 plus ion, and also hydroxide ion. Please make sure you balance the equation first because it's going to affect your calculation later on. So from this equation, 1 mole of calcium hydroxide produces 2 mole of hydroxide ion. If initially we have 0.0011 molar calcium hydroxide, that means we are going to produce 0.0022 molar hydroxide ion at the end of the reaction. So in order to calculate the pH for a strong base, there are 2 methods available. Method 1, okay, we can start by calculating the concentration of hydronium ion. But how? Because from this dissociation equation, we can clearly see that the dissociation of a strong base does not produce any hydronium ion. So, Remember, we can always calculate the concentration of hydronium ion for a strong base by using the Kw expression. Therefore, concentration of hydronium ion equal to Kw over concentration of hydroxide ion. So Kw is a constant value, so just substitute the value of Kw, and then we have the concentration of hydroxide ion here. Substitute the value, therefore bringing up to the concentration of hydronium ion. So we can just calculate the pH value. pH equal to negative log concentration of hydronium ion, and then substitute the value of hydronium ion we got earlier, bring it up to the value of 11.34. So it is a strong base. Therefore, the pH value lies within this range. So we move on to the next method, method number 2. We can straight away calculate pOH because we already have the concentration of hydroxide ion here. So just substitute the value, and then you are going to get the pOH value. But your task doesn't end here because the equation asks you to calculate the pH value. Remember the equation that correlate between pOH and pH. So pOH plus pH equal to 14. So just substitute the value of pOH here. You are going to get the value of pH, which is 11.34. So it's just the same. So it's up to you to choose which method, which is easier. So it depends on you to use which method. Both are correct. So now let's do this together. HNO3 is a strong acid, therefore it dissociates completely in water. So first, before doing any calculation, please write down the correct dissociation equation. HNO3 is an acid, so it's going to lose its proton, forming its conjugate base. Okay, and also H3O plus ions. So remember when we so based on the equation, the equation give you the pH value. So from the equation of the pH, we can see that we can calculate the concentration of hydronium ion by using this equation. So now substitute the value of pH, and then we shift log, or we say anti-log, in negative 2.34. So you are going to get the value of concentration of hydronium ion, which is equal to 4.57 exponent times to 10 to the power of negative 3 molar. So we can construct this table. Okay, why? Because since this is a strong acid, concentration of hydronium ion is equal to the concentration of acid, because the acid will dissociate completely to form the hydronium ion. Right? So how much hydronium ion do we got in the calculation? That means initially we have that same concentration of the acid. Okay, so before we end this lecture, please scan the QR code below for your exit ticket. Okay, I'm going to check through who didn't submit the question. Thank you for watching. Bye.